Hi kids! I'm going to make a little instructional video here about rotational kinematics. So let's talk a little bit about that and make sure that makes sense. Again, I think the probably easiest way to do this is to relate it to first semester with just translational kinematics, linear kinematics. So if you remember, linear kinematics, we had variables, x or y or d. What did that stand for? Oh, that stood for either your distance or your displacement, or maybe your horizontal displacement or vertical displacement. Well, what do we have in rotational? We have theta. That stands for the angle that you sweep out. So where this might be, hey, this is my distance x. Okay. For theta, it would be, hey, this is my angle that I sweep out. Where first semester positive and negative x, positive is in the positive direction, negative is in the negative direction. Well, it's the same thing. With theta, it's, positive. It doesn't really matter what you call positive or negative, but just understand if you have positive theta, that's one direction rotating, and then negative theta is the other direction rotating. A lot of times they say counterclockwise is positive, and then clockwise is negative, but whatever. It's just like we did before. So we had velocity, and remember it could be initial velocity, it could be final velocity, but again, it was a vector. It told you which way you're going. Where in rotational, you're going to have angular velocity. Again, it's going to have direction. So positive velocity means you're rotating maybe counterclockwise. Negative velocity means you're rotating. Angular velocity means you're rotating the other way. You're rotating clockwise. We had acceleration. So the angular is going to be angular acceleration. Again, this should make sense. Okay, acceleration was the rate that your velocity changes. Angular acceleration is the rate that your angular acceleration changes. It all goes together. We did things like, hey, if I wanted to go from this graph to this graph to this graph, if I said, all right, so I have an x versus t graph and it was linear. Well, to go to a velocity versus t graph, you have to look at the slope. So you would have my v versus t graph would look like this. And then if you wanted to do an a versus t graph, you would look at the slope. So then, hey, if I had an a versus t, in this case, there'd be no acceleration. If you're doing a problem where it was like, hey, what if we had a problem where it was accelerating? So you're moving forward, speeding up. Then I'm moving forward, speeding up. Well, then I'm moving forward, speeding up. Well, it's the same thing with rotational stuff. Okay, so if I had a graph where it's like, hey, guess what? You're rotating at a constant angular velocity. Okay, the rate that my angle changes is constant. Well, what does that mean? That means my angular velocity versus time graph looks like this. What does that mean? That means my angular acceleration versus time graph is 0. Why? Because it's not speeding up, it's not slowing down, it's not changing its rotational direction. So if you wanted to, let's say, slow down this time, so you're rotating forward, but you're slowing down. Well, that graph would look like this. You're rotating forward, but you're slowing down. That graph would look like this until eventually you stop. And then you're rotating forward and you're slowing down. That would be underneath the x-axis. So just keep in mind, guys, that this idea of, hey, we have these graphs. Well, we're going to have the graphs. It's gonna mimic just like the first semester. We did, if you guys remember, when we were solving problems. And again, I'm not going to go through and actually solve problems. If you want that, look at a different video. But first semester, when you're solving problems, like, hey, you're going down a ramp, or I don't know, whatever the problem is, you're moving down a ramp, and your initial velocity was 0, and I want to know what is my final velocity, and we measure this distance, and whatever else it is. All right, so if you guys remember, you write down your givens. All right, so I know this. I know this. I'm looking for this. And I don't know, maybe we measured, I guess we'd have to know the time or something else. And then it's, hey, pick an equation. Well, it's the same thing. If I was to draw a picture where it's like, hey, at the beginning I have this thing and it was rotating. So let's say at the beginning it is rotating in this problem. So that my initial angular speed is some number. And then over time it slows down. So eventually my angular velocity is 0. So then my final angular velocity is 0. You could, if we timed it, we could find what is the angle that we swept out. We could find what is our alpha, whatever. Like, again, just use the equations, same as first semester, okay? And then the last thing, and this is maybe the most important thing, is how the heck do we go from translational to rotational? And here's what you do, okay? And some of you guys are like, no, I don't want to do this. Do this. It's easy if you do this. Okay, think about going one time around a circle. So if I go one time around a circle, okay, well, what's the distance that I sweep out? Well, that distance is 2 pi r. That's the circumference. And guess what? That's on the formula sheet. You don't have to memorize that. Well, what's the angle you sweep out? Oh, yeah, that's going to be 2 pi radians. And then if you look, 2 pi r? 2 pi. So guess what? If I want to go from here to here, if I want to relate them, then d is equal to r times theta. Do you guys see it? It's that easy. And then guess what? If I wanted to do, for example, like my speed here, well, that's distance over time. If I go, my linear speed was distance over time. Well, guess what? My angular speed is angle over time. So that this, again, this would be like, average if you're going at a constant speed, but this will give you, in general, like how do we go from one to the other? If you look, oh, wait a second, so I have this equals 2 pi divided by t. Well, really, remember guys, if you remember from first semester, that's really like the period, how long it takes to go around once, and that would be the period, how long it takes to go around once. But the important thing is if you look, how does this relate to this? Oh, right! This is going to be v equals r times omega. Well, guess what? If you do a, it's the same thing. You're going to get a equals r times alpha. And please don't memorize this. Think this step. Actually, really all you have to do is do that first step and go, oh, I know this, and I know this. So this is equal to this times r. And then if you wanted to, you can just do this. Divided by t, divided by t. This over t is v. This over t is omega. Oh, there you go. And then if you wanted to, divide by t, divide by t. V over t is a. Omega over t is alpha. Okay? So that's how you're going to go from one to the other. Hope that helps. Bye, kids!